would like to introduce today's presenter. Dave Nelson is one of our productivity applications engineers in our Omaha, Nebraska office. Some of you may know Dave or Bill from training either at your facility or in one of our training classes. Take it away, Dave.
All right, thank you. So this webinar is based on Haas probing, the WIPS program, and it is going to cover the assembly of the probe, getting all the way to the point of being functional through calibration. So we'll be looking at how it's assembled and how to sweep in the probes and finally how to calibrate. The system has two different probes. You're already familiar with this maybe, but we have two different probes. We have on the left, we have the spindle probe, and on the right, we have the table probe. The spindle probe sometimes goes by inspection probe, and the table probe is often referred to as a tool setter. They also have a numbering system to them, the OMP40 over here on this side and the OTS on this side. The OMP stands for optical machine probe, and the OTS is for optical tool setter. Both of these probes have the same batteries, and I'm going to want to talk about batteries here. And Hope, if you could switch back to me, please.
You're on.
Okay. So I have a probe here, and I'm going to put the batteries in, and we're going to see what that does with the lights flash. And I know when I first started doing probing and had to put batteries in, and it did this flashing, I was sort of like, what the heck? What does all that mean? And so through that, I felt like I needed to understand that. I always struggled with it early on. So what I'm going to do is try to clear that up for you. Okay.
You're back on.
So we have the lights that show. What you see here on the screen is the same light sequence that you just saw with the probe. What I want to do now is just slow everything down and break it down into sections. So these are the lights for the spindle probe, and what I'm going to do is I'm just going to fade out and start with each section one at a time here. So when you see those lights flash, the first three flashes are just LED check. Okay, so it's going to flash red, green, and blue. And because it's just an LED check, if you see that it flashes three colors, you're really done. You don't have to think about that anymore. So once we get past that, it's going to go into this red, red, and a long red. And in this case here, that means that this is a setting, and it is set to optical off. That last red indicates that it's optical off. And what that means, just real briefly, I'm not going to go into these settings really deeply, but there is what's called an OMI that's on the back of your machine, and that's communicating to the probes. So this is how it interfaces. It's called a optical machine interface, and this is how it's communicating. And when we turn it on, the OMI turns on the probe, and if it's set to optical off, then the OMI also shuts it off. So that's all that really is. But the point is that it should be red here. So it's just the last color, the long color that we really care about here. So that's what that one is. And then we would move on. And there's a trigger filter. Again, we don't really care that much about what the setting is, but you should know that it is red. I don't care about the green beforehand. It's always going to be green, green, but different settings might be a different color like green or something, or blue. The next one is modulated, how it transmits information, and then the power, what optical power it's using. And at this point here, I'm just going to highlight just those four lights. And this is all that you really have to remember. So when you put batteries in and it starts flashing these colors, the only ones that I'm really concerned with is the red, blue, green colors, just those. So all the rest of them can be ignored, including the battery status. Really, all I'm really concerned about there is, does it flash all green? So 5 quick greens. If it does, then we're good. Everything is set correctly. Okay. From there, I want to point out that it might not flash those greens, and I'm going to go through a few quick ones about that. So if it doesn't flash the greens, what might it do? Well, it might show you green-blue alternating. If it does this, it means that the batteries are low. And in this case, I would say you should just go ahead and change them right now. So they may be low, but how long will that last? Maybe you can get by with what you're doing at the moment, but I would say change them quickly, very soon. If it flashes 5 red ones, then what that means is that you are in a setup mode. You've triggered the probe while you put the batteries in, and you don't, if you didn't mean to be here, then I would say just wait and try again and try not to have it be that you trigger that stylus. If you do find yourself in this spot, you need to review those settings like we just did a moment ago. Okay, and if you get alternating red and blue, then that means that you are in that setup mode, but you also have low batteries. So I would take the batteries out, put new batteries in, and try again. Another thing that might happen is it might just be red, and it might not even show you any of the other settings at all. It might be when you put the batteries in, you just get a solid red. That definitely means bad batteries and you need to replace them. Okay. One more thing is it could just repeat the LED check. That also means bad batteries. All right. So that was the spindle probe, and I'm going to kind of shorten this OTS one, the tool setter probe. This is what you need to see with that one. So you take the batteries out, wait 5 seconds, you put the batteries back in, and you would get the flashing lights that you see here in the sequence that you see here. And an easy way to remember this is it's red, yellow, green. It's exactly the same as a traffic light. So red will be the first long color that you see, then yellow, then green. And the battery check at the end should be all greens, just like the other probe, and all the same rules apply for the OTS. Finally, with the batteries, I should show you what batteries you want to use and which ones you want to avoid. This is straight out of the Renishaw book, and there's a list of ones that you should be using, what they recommend, and then they recommend that you do not use these, that you avoid these on this side. And while we're talking about batteries, I'm going to mention one more thing here, is that people will ask a lot about what kind of life can I expect, and really depends on how you're using it. But I'm going to give you some numbers here to kind of help you understand what's going on. First of all, the probe, as long as it has batteries in it, it is on. It is on a standby mode, and if you just had batteries in a probe for a year, it would probably only last you about a year. So the standby, just standby, the life that you can expect is about 300 to 400 days. Typical use of the probe, if you're using it every day, but not necessarily heavy use, you're probably going to see around 140 days of use. And if you're using it fairly constantly, then you probably have about 200 to 300 hours of life. So I hope that helps to give you an idea about what you think you can expect. And if you're not seeing that, then maybe you have kind of a problem with your probe that's using that power up a little quickly. Okay. So that was the batteries. I'm going to go now into, well, I guess I'm going to explain to you a little bit about this series. You're in this first one here, which is really focused mostly on calibration. I'm concerned with getting you up and running with your probe. Example, if you had a brand new probe and you were installing it yourself, what that would look like, what you have to do to get it going all the way through to calibration. The second one that'll be a week from today is focused on getting you to a point where you can use programs in process. And I'm going to do that through the conversational programming. So if you're already using your probe and you get code that you typically just hit cycle start and it shows up in MDI, you can take that bit of code and put it in a program, but I'm going to cover that next week to explain what you have to know about so you can make that work decently. And then 2 weeks from now, we'll be talking about macro programming. So it'll be macro programming involving the probing. It's a nice introductory to macro programming if you're interested in that and want to go a little deeper into variable programming on machine tools. So that's what the series is. I just wanted to introduce that to you now. And I also want to point out that this seminar is based on Haas probing, what they call WIPS. And WIPS means Wireless Intuitive Programming System. And that's what I'm covering. We can talk about other ones if you have questions about that, but mainly my preparation has been strictly for the Haas WIPS program. All right, so we're going to get into it here, and first I'm going to talk about some of the things that you need to do your calibration. You're going to need Allen wrenches. I've listed a few here that are the main ones that you would need. Showing a metric set there, but you will probably need a 3/8 Allen wrench to mount the tool setter probe on your table. You'll need an indicator, and I would say you need an indicator with a mag base. You can do some of your indicating by putting it in a tool holder, say like a Jacobs chuck holder. I usually just use what you see here in the picture, just a mag base with an indicator on there. The other thing is, should you use a 5/10 or 1/10 indicator? Well, really you should be using a 1/10. Can you use the 5/10 in a pinch? Probably, but it's, 5 times better to use the 1/10. So I would recommend that. You also need gauge tools. You'll need a tool that'll go in the spindle, of a tool of known length and diameter. And I'm showing a gauge there. You don't necessarily have to buy an actual gauge. You can put a pin in a collet system, but the gauging is not necessarily that expensive. I would recommend that you actually buy a gauge. In this case here, it's hard to see it. I'll try to zoom in on that maybe. You can see that it is actually engraved in here of what size that length is and what the diameter is. And I've listed it over here so you can see it a little bit better. Okay, and you will also need a ring gauge. In this case here, it's 1.5 inches, but you can use different kinds of gauges here as well. Maybe something like if you already use bore gauging and you have ring gauges for that of a known size, you could also use one of those as long as you have something of a known diameter. One of the tools that you'll need is this little spanner wrench in here, this open end wrench. And it's a 5mm wrench, and it comes in a kit that I'm listing the part number here. This is a Renishaw part number. You can order this from Product. You get this whole kit here, plus a few set screws as well. In this case here, you get not only the wrench, but you get the breakaway, which we'll talk about here in a little bit, and the link, the protective link that also marries up with that. So you get a bunch of stuff here for approximately the same price as the actual link here. So I highly recommend getting a kit if you don't already have one. On older machines, they supplied this wrench, this whole kit. Nowadays, they are not supplying that anymore. So if you have a relatively new machine, you might want to get this wrench. Okay. And then as far as gauging is concerned, here's a few different gauges. These are all Redline products. Again, you can buy these from Productivity, and I've listed the part numbers here. So the top one is Cat 40, and the second one is Cat 50, and then this is a ring gauge down here. So just wanted to make sure that I provided that so that you can, if you were looking to get one, that you would have something that you could order. All right, so we have our two probes. I'm going to start with the spindle probe here. And here we have the 40 taper holder that the probe attaches to. And I have an Allen wrench in here that shows, I'm going to switch this, hang on a second. So you see I have an Allen wrench here in this hole. These holes here are mounting holes, and we'll look at things a little closer here in a minute, but these are the mounting holes, and then these holes here are for dialing it in. And the mounting ones, there's only two of, there's one here and there's one 180 degrees over, and the dialing in ones are at every 90 degrees around that circle of this cylindrical surface here. And over here on this side, there's this surface here. This is really the only locating surface for the probe attaching to this holder. This is not a locating surface, just clearance for the stem to go into, and we use these screws to dial it in to get it on center. So that's how that goes together. And I recommend that you don't over tighten things. That's one of the big things. Don't over tighten. I should also point out, I don't have a picture for it, I'm realizing, but there's different set screws here. One set screw on this one here, and on the one 180 from it, have a conic end on them. And I'll show you what I mean by that here in a minute. Okay. You also need a stylus, and I've just included this here so you can have the part number for this. This is the Renishaw part number for the one that comes with the machine. I'm listing here that there are many options. So they're all ruby diameter balls here of precision, but you can get different sizes from 1 millimeter up to 8 millimeter, I believe. This is a 6 millimeter. And it's 50 millimeter long. You can also buy extensions for this, so you keep using this one, but you needed a longer one. You could buy an extension just to make it longer, but you don't have to necessarily have a really long stylus for all of your work that you might be doing. So extensions are a good idea. And then there are different materials for the stem here. This is ceramic here. When you see white, that's always ceramic. There's also stainless steel, carbon fiber, and tungsten or other options. They're all meant to break though. So that's the idea here, that you break this and not break your probe. All right, so here's a little drawing of your spindle probe. And I got an overall picture up here. And we'll go over into that. So all I'm doing here is I'm going to zoom in on this section here, down here. And I mentioned the conical set screws. So these set screws here they're conical because they're mating with this blue sort of a washer that's inside there. And when you tighten these up, it pulls the probe up against the surface up here. So where this mates right in here, it pulls it up in there so that it's mated, and then you have these set screws here that are flat that are for dialing it in. And as far as dialing it in is concerned, if you've ever dialed in a 4-jaw chuck, then you kind of already know how to do this, all right? and I'm going to show you a little video here. So what I'm going to do here is you can see I'm going to turn this and you'll see this indicator move, and it's going to have about 5 thousandths of swing in here that you'll see. And what I'm going to do is, if you noticed that I was at where there's 2 holes here, where I was at the extreme, and I'm going to go to where it's 0, and I'm sorry, there's where it's 2 holes. And 1 hole when it's at extreme. I said that wrong. Okay, and what I'm going to do is, when I tighten this screw up, you'll see that it'll move closer to 0. So right now, the probe is actually too close to the camera. And when I tighten that screw up, it's going to push the whole probe away, and the needle will move closer to 0 here. I'll test it again. Tighten up a little bit more and get a little closer. This is basically what you need to do, is just keep working with the ones that are the furthest out, like you would on a 4-jaw chuck. Try to get as close as you can. What kind of runout are we looking for? So I've seen a number of different things published. I would say that if you're within 4/10, you probably are pretty good. I have seen some things published where they say 1/10. And I want to explain why someone would say that it needs to be so nearly perfect here. The reason is, if you don't make sure that you have the probe in the same way every time you orient, like right now what you see is, you see this Haas logo kind of facing you. If this was oriented at this point and you saw the Haas logo, if you took the probe out, when you put it back in again, you'd want to make sure that you are putting it in there this same way. If you didn't care about making sure that you had it in there the same way, then you would definitely want to make sure that you dial it in to 1/10. So that's really the difference here, is trying to make sure that you either sweep it in very, very good so it doesn't matter which way you put it in, or maybe a little bit more and you always put it in there right. People do it different ways. The best thing, of course, is to always make sure that you put it in the same way and go ahead and dial this in as good as you can. Okay, there's that. Skip that now. So the tool setter probe. So on this one, I've zoomed in on the stem here, and this is the probe over here. And just zoom in a little bit more, we're going to look at this. So this section in here, what you see here, is a breakaway. Okay, so if we push too hard on the stylus up here at the top, then this is weak right here and will break and not damage your probe, hopefully. The link in here is to hold on to that so you don't lose it in the chips. And there's the assembly of this. So we put the stylus, this is all the stylus here. It's held in there with this set screw, and this body here is connected to that stem through this set screw. And you put the breakaway in here through the link, and then the link comes in here with this cap screw underneath, and that's how you assemble it. We'll look at pictures, a few more pictures of that in a minute. Here I've given you a few different views of the mounting ring, and I kind of want to clear some things up on this. So what you have here, one view of it here, you see that it's really 2 rings. It's split in the middle, and I have the T-nut underneath here too. It has a snap ring up here at the top that is actually used for the mounting. So there's set screws that go underneath that to pull the probe onto this ring. And you also can see over here a pin. This is an orientation pin, which we'll see where that connects to the probe itself. There are 2 screws here. One of them pushes and lifts this upper ring up, and the other one pulls it down. So this is how we do one of the adjustments on getting the probe parallel to the XY plane. This middle one, you see that there's a pivot point here. There's something inside here that allows us to pivot, and this is the opposite side of these screws. So when I push or pull on here, I'm moving that top ring and tilting it against this pivot point here. I'd also like to zoom in here a second and show you there's a little split right here in this ring. And I always try to make sure that that is sitting not where a screw would hit it. So I don't want the screw to kind of bump into that ring right there. So it's just something that I try to do. Then the underside, what you see here, this hole here, this tapped hole, is actually this bolt going through. So this one lowers the top ring by pulling it down through this tapped hole, and the other screw is pushing, and there is no hole through that is pushing it up. So that's what you see there. These two screws here are actually holding the two rings together, and also the pivot point piece that's inside there. But there's a couple more holes here that I want to talk about that aren't always even talked about. There's these two holes here, and what they are is pinholes, so that you can actually mount it to a fixture if you wanted to. So it kind of helps so that you can have it where you can remove it a little easier. Of course, here is the probe itself, and this is where I want to show you where that orientation pin connects. So the pin that we saw where we talked about the orientation ring, our orientation pin goes inside of this hole here, and there's a set screw on either side of that pin, and that's to provide a fine tuning of the orientation. Now we're typically using round stylus, so it's not that critical of an adjustment, but still something that's there that we have to kind of contend with, and it can help you locate a little closer and repeat better by having those screws there. So we're going to look at some assembly here. I kind of touched on this a little bit earlier, but how you assemble this is you have the breakaway here that goes through that link, and it goes into the probe. The stylus goes into this body here, fastened down with a set screw, and then that assembly goes onto this breakaway and through this link here, and that's how it gets assembled. But I want to also show you how it connects with the mounting ring. So you just mount through and onto a table or a fixture if you have something to hold it with, which I'll give you something on that too in a minute. And the screws that I had mentioned, there's 4 screws around the outside of this that are connecting to that snap ring to hold it on. That's what those are. And when we're putting the tool setter probe on the table, we have to consider, well, where is it possible for the OMI to read the OTS? Is it able to see it? If not, then we can tilt it if need be. You pull out this screw here, you have to pull it all the way out, and then the body can be tilted so that the window that's right here can look at that OMI. Another thing that I want to point out here with this is that sometimes people have something over on the right side of their table that kind of make it difficult to put the probe on the right side, which is typically where you see it. Here's just an example where someone has a extension mounted on there so that the probe sits higher and back behind a little bit of this chuck on this rotary table here. So this is just a kind of an idea. There's a lot of different things you can do, but in this case here is sort of a perfect spot to put it kind of nestled back in behind there And another thing that you can also get is there's different people make it. Here's this one by Fifth Axis that is a quick disconnect. So you can just one screw, loosen it, take this whole thing comes off, and then you can just put it right back on again. So this is kind of a neat quick change thing. And there's various different types, or you can make your own. Some people do that. All right, so here's a drawing of how this is assembled and how you dial it in a little bit too. So I talked about that pivot point. I have the red circle here showing that pivot point. And you see that there's conical screws in here that are pushing against that ring to draw the probe onto this flat surface of the ring. And then I have a couple of screws here that one is pushing and one is pulling. And it also shows you here the dowel pins, the holes there, and they're 6 millimeter. So you can put dowel pins in and mount to a fixture if you wanted to. All right, so here's a little video. I'm going to show you something that's kind of important here. These top screws, I'm going to loosen up this screw in the video, and you're going to see that this section is going to kind of pop loose a little bit, and this can be a problem if it's not seated in there. So this is what this video is showing. So you see it popped out, and I popped it back in again. If for some reason you went real loose with this screw, with both these two top screws, then it can be where the probe's starting to come apart, and that's what I wanted to warn you about. Most of the time, I do recommend that you loosen up screws to do this dialing that we have to do to get this parallel to the table. But if you go too loose, then you start really disassembling the probe, and we don't really want to do that. There are wires in there and so forth. So that's just a cautionary thing there. And this video is showing you that orientation pin. So the orientation pin is underneath here, but it's kind of still loose. The probe is actually just sitting. It's not attached at all, sitting on that mounting ring. You can see that I can wobble that. So you just want to try to get that fairly square. You don't have to really fuss over that, but those screws back there can help you get that square. So I just wanted to show you that. All right. And then this video is going to show me dialing this in. And this can be kind of a tricky maneuver. So here we have the probe in here. You see I have an Allen wrench in this screw here on the back side. That is the one that raises the probe on this side of it. We'll watch that real quick. Now, if you notice there, that really was only about 3/10 difference in what it was across there. But because this is only a 1/2 inch wide in here, or really even less than that because of the indicator, that 3/10 does not really give you an idea of really how far off you really are. You'll watch now the adjustment that I make. I'm going to move it approximately 3 thousandths, and that was just about right. Now it's only 1/10 off. So my point here with this is that when you go to sweep this in and you move it, if you saw 3/10, you go, that's pretty close, I'll move it 3/10, and then you try again and you realize that you didn't really make much of a change. Understand that when you're dialing this in across here, you're going to move it more than what you think. Okay. So then here's another drawing, kind of show you a few things here. Again, they recommend 1/10 of flatness here. So when you sweep this in, you want to have total indication of approximately 1/10. And these are the screws. You kind of see it here. I'm going to zoom in. So the screw actually comes against a machined flat in there, and that's what's actually tilting that part of that. This is also kind of holding it in there, so it's possible for it to kind of pop loose here if you loosen this up too much, because if the screw is all the way out, then there's really nothing holding that in there anymore other than an O-ring inside there. So we kind of saw that loosen up, and we saw that I can actually rotate that back and forth when that's loose. That's what you're dialing in this way. And we also saw a video of dialing it in the other direction along the what would be the x-axis. So big thing to remember is about 1/10 to dial that in. Okay, so now I'm going to go into the calibration aspect of this, which is really the easiest part. Haas has made this very easy with their intuitive programming and visual programming methods. But before I get into that, I do want to show you this slide here, which is indicating to you how to just test, just activate the probe. And by using this, you will be able to determine whether or not everything is working from, I'm going to say, the hardware end of things. So if everything is working, when you run this code in MDI, you would see the probe turn on and start flashing green. And that means it's on, and you can even reach in the machine, open the door up, reach in and tap the stylus, and you would hear it beep. So if all that's working, then you don't have any kind of hardware issues. The probe is functional, and all the hardware inside the machine that communicates to the probe, all those things are working, and it's not that end of it. If you're having problems with the probe, at that point, it's not a hardware issue. It's going to be a software issue of some sort. And I've got this broken down in a couple of different things. So many of you probably have classic controls out there. These are the codes that you're going to use for the classic controls along this vertical here. If you have next gen, then you would use these codes on this side. And the table probe is turned on with this code and this one, and the spindle probe is turned on by these. And you can just hit reset and it'll turn them off. So just a quick thing on that. That's a way of testing the probe. All right, so we are going to go into the screens of what you have to do the calibration. And I'm going to start with the next gen control, and then we'll kind of touch on the classic control as well. So from here, what you're going to want to do is hit edit. And if you hit edit a second time, it will bring you to what you see here, where the word editor is highlighted in orange like that. And then I will just want to move over to VPS. And what you see here, there's sort of two parts to this screen. There's this top section, which is recently used probing cycles that have been used on this particular machine. And when you arrow down, I'm indicating over here, it'll bring you down, right down here to the directories, okay? So it's going to bring you down here. It'll skip this. But if you did want to use something that you've used before, you can switch to this up here by hitting F4. But I'm going to skip that and just talk about these different sections down here. So to go into probing, a little indicator to me with this is that if you happen to see the word, the indicator that it's a directory here, that means you have to go into it by going to the right. And this little arrow here is sort of indicating that too. So this, you can think of this arrow as meaning if you want to go in there, you're going to have to hit the right arrow key, which I will do now. And oops, I'm going to go now, okay. And then I'm going to come down to the calibration section and go into that by hitting the right arrow key. And then you're going to get this screen. Now there's various things in here on the next gen control. We're not going to talk about these directories up here. These are different things that you could be doing, but we're going to skip those. And you see that there's 1, 2, 3, and 4 here. There's 4 different things that you could do to calibrate. I am not going to talk about the complete probe calibration. I will just kind of briefly touch on what it is. So the complete probe calibration is all set up, ready to go. If you're going to calibrate my recommendation is if you're going to actually calibrate daily, if that was something that you wanted to do, then you could set it all up where you have your gauge for touching off your tool setter in the machine in a specific place in the machine, all ready to go. And you can just run this complete probe calibration and it'll go through and do the entire process, including the spindle probe as well. So it'll take care of everything. I'm actually going to skip that and go into 2, 3, and 4, these 3 steps. These are very similar to what you would do on the classic control as well. So the complete probe calibration did not exist on the classic control. It's a new thing on the next gen. So we're going to go into this tool probe calibration and go into that. Oh, I'm sorry. And to do that, we hit enter. Okay. So once you have it where you've got, it doesn't say directory here anymore. If you just see numbers that show the size and doesn't have the arrow over here anymore, to go into it, it's not the arrow anymore. Now it's enter. So we're going to go into that. And it's just a matter at this point of just answering the questions. So we're going to punch in the length, diameter, and the orientation, and we'll kind of walk through that a little bit. So the length and diameter, we just have to remember, well, what was our length and diameter? In this case here, it's engraved on my tool. I can take a look at that, or you can have it written down somewhere. You're going to want to punch those numbers in. So I would be changing these to the numbers that I have over here on the left. And then the orientation, this is the screen that you will get for that. And this has to do with how does it sit on the table. So the typical one is this number 1. This is usually how the machines are shipped, with the tool setter sitting on the right side of the table and oriented like what you see here if you were looking down at the table. Typically speaking, you want the probe as much as possible coming off the table, so it's out of the way and you're not really, using up valuable table space. If you were to put it on the left side of the table, you'd probably use this number 3. It's fairly rare to use the orientations that are going along here vertically, but it's possible on the next gen control through selecting whatever one, however it looks. Okay, so we'd punch that in there, and once we have all of this all filled out, we would just hit what it shows up here to run it in MDI. We just hit cycle start. And also, I should point out that going back to this OMI connection, this optical line of sight thing, whatever you do when you put, however you want to put your probe on your table, you've got to make sure that there is a line of sight. So you may have to readjust this if you are switching that out. Also possible that you may have to move your OMI. In some cases, what I've done is actually remounted the OMI to be at the ceiling of the inside of the enclosure, so it looks more directly down instead of at an angle from the side, and that can help quite a little bit as well. Okay, so here's a calibration in process. So this is what it's going to look like. You have to position it there close so that it can do this, and this is it takes a little while to run this video. It's going to come down and set the Z first. When it's done with that, it'll come back up, and then it's going to do around the sides. So let's do one side, then the opposite side, and then the front and back as well. So what's happening here is it's getting the location of that stylus in all 3 axes. So the first coming down, of course, was Z, and we're now doing X, and then we'll also do Y. So it records where that is. So if you ever move your probe, of course, you're going to have to do this calibration because it's learning where that stylus is. It is also measuring the size of the stylus as well. And all that information, all the calibration information is all stored in macro variables, which maybe it's a good time to talk about that. If you're having problems with probing, typically speaking, the problems that you have are going to fall in within just a few different things. And one of the biggest problems with probing is actually the batteries. If you're having problems with probing, you want to at least check the batteries. And outside of that, it could be the probe settings. So I showed you the flashing lights. You want to go back and review that, make sure none of those settings had gotten changed. And then it could also be macro variables or macro programs. So either your variables got corrupted or your programs got corrupted. So to correct those, it's a matter of if it's the variables, you can clear out all your variables and recalibrate. If it's the programs, you would reload all the macro programs for probing back into the machine and try again that way. So that's really, most of the problems are resolved with those things. It's either batteries, number one, or a lot of times problems are just fixed by calibration. Also, the problem with probes can be that just how it was assembled. So if you assembled it poorly, like if you used the flat set screws where you should have been using the conical ones, it could be hard to dial it in or hard to keep it dialed in. If that's the case, then you should go back and just check that assembly, see if maybe there's something wrong with that. Also, I showed you the video where the tool setter probe kind of popped apart a little bit. If that's loose there for some reason because those got loosened up and it kind of popped loose a little bit, it could be unstable, not seated nicely, and so it keeps moving on you. Could be something like that too. So assembly is important here too, just to make sure that it's rock solid, because what we really want is a nice, reliable probe, and the assembly is part of that. So now we're going to move on to the length calibration. So this is where the two probes meet, and we're going to set just the length of our spindle probe. Go into that screen, and it just wants to know what tool number it is, and chances are you have it in the spindle, so it's kind of ready to go, and it would have 30 there, okay, or whatever tool number it's in. For me, it was 30. Here's a little video of that. Short and sweet on that one. So it is doing a few things here, actually. It is getting the length, and that length is just going into the tool offset page. So in my case, tool 30, so offset 30 will have the length of this probe. It is also storing that information in variables too. And on more recent machines, I think only on next gen, but I guess I don't know exactly where that is, where that change occurred. But they actually stored it in a few places. So there was actually like 3 different places where this information was stored. If any of those numbers change, if they don't all 100% match, then the machine will actually tell you that you are not calibrated and you'll have to go through a calibration process. Example, if someone accidentally changed the tool probe's length offset by even 1/10, then it's going to come up and say you have to recalibrate. So that's sort of a safety as well. All right, the last one is spindle probe diameter. So this is it's going to figure out where this ruby ball is in comparison to the center of the spindle. So when you dial it in, if you were off 10 thousandths, it's actually going to figure that out and set variables so that it'll compensate for that 10 thousandths that you're not on center. So it actually does a pretty good job of even if you did a poor job of dialing in the stylus, this will compensate for that. Okay, plug in your diameter. In this case here, my diameter was 1.5. There's the 1.5. And here's what that looks like. Again, with this, you have to put the probe in the ring, okay? You have to have it there to begin with. This point. So it turned 180. If you notice that this turned around, so it's doing it again. These two bits of code here we're setting up to find where the center of this gauge is. Now it's doing the calibration. All right, so I do want to mention one more thing with this. You see that it hit on those 4 quadrants of that ring gauge. At this point here, the only way that we can probe anything is on those 4 cardinal points. So only at 0, 90, 180, and 270 degrees. There is no other angles that we can set. I'm not going to cover it in this webinar, but on the next one, I will talk about another way of calibrating this where we can get the every 30 degrees. So we can actually do another calibration process where it does 0, 30, 60, 90, all the way around every 30 degrees. You'll notice though that I didn't mention 45. So you cannot probe at 45, but you can probe at 30 or 60. So if you needed to avoid one of those points, we can do probing that's called 3-point probing. Not something that we're going to be covering in this particular webinar, but in future ones we will be talking about how to do that. Okay, so we're almost done with this. All I'm going to do now is cover the same thing but with older controls. So this is what you would see on your classic controls, and to get here I'm going to press MDI and then I'm going to press program, which is going to bring me over to this side over here, and I would move tab over all the way to the point of seeing VQC, and you would see this screen then. And so we have 1, 2, 3 different calibration processes which are matching up directly with what you saw in the next gen control. So this one's going to touch off and set your tool setter probe. The second one is going to take care of the length of your spindle probe, and then this is finding the XY with a ring gauge. So those are the 3. I'm going to look at those screens, so I would hit enter to go in here, and I would see this. And it has directions on here. You want to make sure you follow the directions. It wants the tool length, we'd punch that in. The tool diameter, punch that in. And then it wants to know a side. So we saw this with the next gen control, it was 4 options. On the older controls, it only has 2, either the probe is on the left side of the table or the right side of the table. So right side of the table, we put 2 in here for side, or if it's the left side, we'd put in -2. So the probe itself is actually oriented that way. On the right side, the stylus is to the left, like you saw with the next gen control, and then vice versa for if the table probe is on the left side of the table. So we punch this in, hit cycle start, and it does exactly the same thing that you saw in the videos previously. This one is the one that you use for the Z offset for your spindle probe. And in this case here, on the older controls, it always leaves this blank. You're going to punch in whatever the tool number is for your probe. On the next gen, it just assumes that it's in the spindle and then plugs in whatever that is. So here you have to type it in. Then cycle start, and it runs it. And then finally, we have the ring gauge. You just punch in the diameter of the ring gauge. And at that point, you have both of your probes are working, and you should be able to use your probes at this point. So that's assembly, dialing the probes in, and calibration. And that is that.
Great, thank you, Dave.
Mm-hmm.
So we are going to open it up for questions now, and we do have a few questions for you guys. So okay. We do have some teachers in the audience today, so thanks you guys for joining us as well. First question we have is, can we use this recorded series in our classes?
I would assume so.
Okay. That's what I
no one's talked to me about that before, but I'm assuming yes. I don't see why not.
Okay. And would you feel it's okay to share a link to the training with students?
Sure.
Okay. Matt has a question. If you move your OTS, will the machine pick up the new location for calibration? Right.
That's you actually have to just perform the calibration process. So if you move your OTS, you're going to have to do the calibration process again.
Okay. Mike is asking, how can you back check the known tool length after a calibration to see if it was done correct?
I would say that you zero things out and zero out your variables and run a calibration, and you'll see that they've changed. You have no way of referencing what number it should be. The machine is doing that measuring. So the only thing I could say is that you could test it, probe something that you know where it is and see what you get and see if it's probing properly. There's no way to know, like, it should be a certain number and you can go look and see the number and yes, that's the right number. There's no way to know what it should be, so not that easy to do. I don't know if you have anything to add to that, Bill.
Yeah, I'm not sure if the question is just double checking to make sure you have the right tool length, but you could do you could probe it as if it's a tool if you wanted to check your calibration tool. I'm not sure exactly what the question is referring to, but hopefully you'll get the same answer. If you measure your gauge tool, again, you better get the same number. So.
Right. Yeah. Just that's you just have to test it to see.
Okay.
Okay.
All right. Thank you. What is the part number for the breakaway piece of the tool probe?
That will have to be something we can get to that person. Do we know who that was? If we know who that was, we can certainly send it to them.
Okay, sounds good.
I don't have it right here in front of me.
Okay. And Tim is asking, how do you change the spindle probe stylus size? He was told that he could only use the standard 6mm ball.
Oh, no, that's not true. You can just change your stylus and recalibrate. You can use almost any stylus that you want. Just always a ball. I would always recommend a ball rather than anything else. There are discs type ones, but those are rarely used. Now you can switch to whatever stylus that you want. There's various different lengths and diameters. If you change, you have to recalibrate.
Okay, thank you. Why would I want to probe on an angle? All default. Haas probe options are square to the machine.
So why would you want to? Well, an example of that is if you have let's say you have a hole that has a keyway in it. So where you have that keyway slot happens to be right at 0 degrees. The probe is going to try to hit there. So if there's nothing there, there's a slot there, then that's not going to measure properly. So you would want to try to avoid that, and that's why you would change angles.
Also, I'd like to mention
one example.
I'd just like to mention, Haas has put these, we'd call them can cycles in there. They're the most popular way of probing, but that's far from what the probe is capable of, and there are endless cycles that aren't in here. So maybe David mentioned earlier, maybe they don't have a full circle to probe and they only have a half circle. They can do a 3-point. It's not something you're going to do in a can cycle situation, but we can write a custom macro, and that's something we'll see in the later presentations.
Right. Exactly.
Okay, thank you. Next, I have a TM1P with Classic. When we run the tool length measure rotating for face mill, it locates 90-degree different than it used to. Our VF2 still does it with face mill to the left.
Oh, the way that it touches the tool off, maybe. You know, maybe that's something where I think that's going to be something that may require more in-depth. So they can email the training nebraska@productivity.com, which you I think we still see on the screen, right?
Not yet. We have you on the screen.
Oh, so there's an email that you can email to get additional information and also ask further questions, follow-up things. If it's more in-depth type things, you can email trainingnebraska@productivity.com. I can put that back up.
I'll put it in the question and answer too. I'll put it in the chat for everyone right now.
Okay, thank you. Okay, Zach is asking, for the tool setter probe, is the tool length from the tip of the tool to the face of the spindle or to the face of the holder? On the Haas machine, there is a gap between the holder and the spindle face.
Right, it's actually it depends on how you calibrated it, what you used to calibrate it, but it's from the gauge line of the spindle, which is, it is a space between, there's no reference, it's in the middle. It's between the spindle face and that flange of the tool, somewhere lying between there. The reason for that is that spindles can be reground, and you would lower that gap that's in there would shorten. And so the actual gauge point is sort of a industry standard place, and it's not, it's an invisible line in there. So that's where it's coming from. It's in between. And if you buy a certified gauge, the tool length gauge, it's going to be at that gauge point. I hope that answers the question.
Okay, thank you. Carl's asking, can you use rechargeable batteries with the probes, or are they recommended?
I have never heard of anybody ever using them. They're not on the list of what is recommended, so I would say probably not. I believe that the batteries are selected specifically to have a certain characteristic as far as how they die, that they kind of die quickly. Bill actually may be able to add some more to that.
Yeah, the batteries for the probe are 3.6 volt lithium batteries, and if you have a chance, Haas has a great video on this. Mark Terryberry does on his tip of the day, but lithium batteries, their life is like a cliff. So it goes along flat, and then all of a sudden it drops off. And the only way you can check them is under a load. So you can't just put a voltmeter on them and say, hey, these are good. But an alkaline battery starts fully charged and declines on a slope. So I don't think the rechargeable, or I'm sure they're alkaline batteries, I don't think they would work just because of the way they hold the charge and lose their charge. So I think you want to use the lithium batteries.
Yeah, you really want batteries that are going to stay fully charged until they die. You don't want them to just kind of gradually go, because you don't want the probe to reach a point where it's kind of flaky, where well, maybe it works, maybe it doesn't work. You want it to be able to work, and when it starts up again and they're dead, then they'll be dead. So it's not something you want to play around with rechargeable. It's unfortunate, but that's the way that it really should be.
Okay, thank you. Okay. Dale's asking, when probing a bore, how close to the center of the bore do I need to jog the probe?
My general rule of thumb with that is that if I can eyeball it, then I'm there. You can just use the best tool for me is either just a machinist scale or a tape measure. Just kind of, if it's a rather large hole that it's hard to judge where you are in the center, I just kind of lay the tape measure in there and just judge it based on the tape measure. You don't have to be really that close. I would say you can definitely be off by 1/8 of an inch, but probably more than that.
We didn't show probing a bore in this video, but what it does is you just get it close, it probes for location, recenters, and then it actually probes the size of the hole. So you just have to be close.
Okay, thank you. David is asking, how consistent should the OTS be? If I probe a tool, what's an acceptable change in length if I report it later in the day? Reprobe it later in the day.
Well, there's a number of factors that could cause that to not be consistent, which have nothing to do with the probe itself and more to do with the machine and the temperature in the room. If we're talking about maybe the day starts off cool, but gets blazing hot later in the day, and you probed it in 2 different times, the machine itself is actually what's measuring things. So remember that the probes are really only switches. So the machine's doing the measuring. So if the machine has thermal compensation issues of some sort, then that's just going to translate to the probe as well. What can you expect? What should you be able to expect? You should be able to expect very good results. So if you're not seeing that, I would say, we can certainly examine the machine, but we would also want to know about, are there, how consistent is the temperature in the room, and how old is the machine? How well does it even hold tolerances when it machines? Are going to be things that we're going to want to know about. So that'll be something to have to explore on a case-by-case basis.
Okay, thank you. Mike is asking, is there a way to lock the tool settings for the spindle probe? Sometimes our students delete this.
So the tool settings, well, yes, there are ways of locking things out. We can lock out offsets, we can lock out variables and so forth. There are settings that control that. So yes, there is ways to do it. Unfortunately, by locking things out, it also means you can't do things too. So I don't know what to tell you on that exactly. I think that it could be a problem to try to lock them out, but you can certainly try that. There are settings that control that.
Okay, thank you. Mike is asking, how accurate is it to calibrate a spring-loaded probe with another spring-loaded probe?
Oh, so you're probably referring to the fact that we're setting the length of the spindle probe with the other probe. Well, this works pretty well from what I can tell. I understand why that's possibly an issue to you. There are other ways to calibrate that. So if you don't like that and you think that that's not very good, then we can certainly change that. But I rarely see any problems with this method. So I don't think you should have any problems. But if you do, we can change that. Another thing we could address at a later date.
Okay, thank you. Ed says, I have a dimple in the OTS pad. We were thinking about regrinding flat, but it's about 1.001 plus. So when we check the level, it has that dip. I'm sure we can just replace this. Yes,
that's what I would do, is replace the stylus. That receives a bit of wear because especially if you're using carbide, it's carbide. And so you are going to see wear on there. If you spin tools when you touch them off, then it's going to receive a bit of wear from that. I don't know if that's what it was, but yeah, some people seem to see a lot of wear, however they're touching off their tools, or maybe how often they do it. It's going to wear out maybe sooner than for other people. So if you're seeing that, if it's been there a while, maybe just get a replacement.
Okay, thank you. And Mike is asking, I usually buy the batteries from MSC, very expensive. What do you think of the battery store chain for a source? I hear that they are about 1/4 of the price.
Yeah, I mean, wherever you can get batteries, we also sell them too, so you can buy them from us. I don't know what our prices are like. But yeah, as long as you're buying, you know, the recommended batteries and avoiding the ones that they are saying to avoid.
Okay.
Wherever you get them from is fine.
Okay, let me just make sure I haven't missed anybody here. Okay, are there any other questions? I know that there's a short delay in here. Okay, well, if you have any further questions, you can please feel free to email trainingnebraska@productivity.com, and I will also be sending out a follow-up email to everyone attending today and registered. So if you have any further questions, just shoot me an email back and I will make sure those questions get answered. So if there aren't any further questions, I would like to say thank you again to today's presenter, Dave Nelson, Applications Engineer from Productivity, and Bill Schnitger, also Applications Engineer, for answering the questions in our Q&A. Again, we thank you all for taking the time to join us today. We hope you enjoyed today's webinar and look forward to seeing you again soon. Please remember to join us next Wednesday for week 2 in our probe series, Beyond the Setup in Process Inspection. You can register for these either through the email that we send out, or if you visit our website, we also have a link there. So thanks again for joining us today. We ask that you stay safe, stay healthy, and thank you for your business. Have a great day, and we'll see you soon.